we will learn about light. First, what is light? Where it comes from? What it does to you? And finally, that you are made of light. Sometimes it gets dim and sometimes it shines. So to begin with, I will show you a small science project. Everybody has this experience, right? You have a glass or can or something and you put the straw and you drink from it, right? Everybody has done that.
I don't know. No.
Okay. But have you noticed? You watch this straw carefully, okay?
Yeah.
And I'm not touching the straw, I'm not touching the glass. Right? Just watch this. I'm going to pour water in it.
What are you going to do with it?
What has happened? The straw is broken. Right? It twisted up to the wall, up to the water top of the water level. It is straight, right?
Yes.
And then it got twisted. What happened?
It's broken.
Yeah. When you put the spoon will not straight line, so spoon will look like it's more bent. It's bending. But this is a straight line and it got broken. Who broke it?
The water.
Water break it? Water didn't do anything.
Light.
You just put the water. Is this broken? It's not broken, right? It's still not broken. But why do you see it broken?
Because of the reflection of the
Reflection of what?
the mirror.
Where's the mirror? There's no mirror.
This is good.
Only why at the surface the straw got broken.
It looks strange.
Okay, to know this, you have to know something where light comes from and what it does. You have heard me explain to you that light travels very fast, right? Very fast. In 1 second, it's going to go many times around the earth. But
No.
light travels very fast in a vacuum. Vacuum means there is nothing there, not even air or gas, nothing is there. And there are parts of space where there is nothing. If there is something, they destroy each other and make nothing comes out of it, right? There are positive electrons and negative electrons and they meet and they finish. So there is nothing. So when there is nothing, it's a vacuum, everything has been taken out, light travels very fast. But if there is something along the way, even gas, light slows down just a little bit. And the more thicker, heavier place area that light passes, it slows down even more. If I put a piece of paper and have, oh, did I bring a flashlight?
Yeah.
Okay, it's in the drawer somewhere. Can you bring it?
Need a phone flashlight.
Oh, yeah, give me.
Yeah,
Give me. Okay, give it to me. Okay. So when the light is on, see, if I turn from here to here, you will see right away, right? But if I do this along the way, on the other side, you will see much less light, right? And if I put like a metal sheet, you will hardly see any light coming from through it. light may come around it, right? Light is coming around it, right?
I'd still see the more light.
You still see the light, and light is coming around here. In other words, if all the lights, I'll use it for another minute, if all the lights in the house at night are switched off, all the lights, but one room you switch on the light, what happens? The whole house gets a little bit light, right? It gets a little bit light because light goes all around, less and less.
No, dark. No.
Yeah. But if you build a room made of steel, metal all around, and close all the doors, and put a bright light outside, unless there are cracks in the door, windows, some light will come, but most of the light will not come, which means light has slowed down and stopped. Okay? So what is happening here is above, now water is something heavier and thicker than air. So in this room, light will not travel at the speed of light. Okay? Light will not travel, it will a little slower, or still very fast, much faster than sound. If the light is closer to the sun, it will twist. It will go from here, go toward the sun, slide and go further. But it cannot go through the sun.
But Dada, like if we pointed a flashlight at the sun from here, we would not see the light.
It will get lost. Okay. So what is happening is when there is more massive stuff is in the way light slows down. If I put water from the ocean, now ocean water is heavier than this water. This will be even more cut off. You'll see one here, one on the other side. What is happening is that up to here, light is going at the same speed, up to the surface of the water. Then water, light little bit slows down. So in lower part of the straw, light doesn't reach at the same time as this. So you will see this part either bent or split, and you will see just a tiny fraction of a moment later, because water takes a little bit longer to reach that part of the straw, and also a little bit longer to come back above the surface in the water. So in water, light travels slower. This is what is happening.
And that is called?
There is one word for it, and it's called refraction. Refraction. You know refraction? Refraction,
Yeah.
which means another fraction,
Yeah.
is splitting. Okay? So the word is called refraction. R-E, and same spelling as refraction. So one quality of light is that it refracts. Listen, light, Jay, you understand, right? You're an energy expert. Light refracts depending on where it is passing. In the atmosphere where there is only air or gas, it will reflect and bend a little bit less. In water, it will bend and refract a little bit more. On some solid, on wood, it will reflect a little bit more. On metal, it will reflect refract even more. And sometimes it will reflect and move back rather than refract. Instead of bending, it will come back.
Actually, when you see the sun, it's already passed through the atmosphere, so it's already been refracted a little bit.
It is
So actually, the sun
yeah.
is not right there where you see it. It's
So,
actually
so the thing is that if I take anything, if I put it here and drop it, it will fall down, right? But if I turn the light up, does it fall down?
No.
Underneath is still dark. Around is dark. There is a little brighter. Why doesn't light fall like everything else?
Light.
And that is because
It's
light is nothing. What does mean light is nothing? Light is not a thing. It's just a wave. It's just moving. It is not something moving. Right? If I pour water, water is something. It is moving. It is flowing.
like in a stream.
My hand, my arm is something. Is moving. But light is not a thing. It is not a thing. Now, what is a thing? A thing is which has matter. What is matter? Where atoms are together. When atoms are together, it is matter. When lots of atoms are very much together, that measures the mass. So matter is something, mass is how tight it is. This has more mass than this, right? This has atoms together. Something more solid has more atoms packed tight. Something where atoms are far apart is light, soft. Wood in the same area, same piece of wood, has less mass, which means the density of that thing is more, is less than metal. Metal is tight. Rock is also tight.
That's it.
Okay?
No.
So light has no mass. It is only a movement of energy. Now, when something moves very fast, now a mass is something that needs energy to move. If there is a ball, if I roll the ball, it will stop someplace, right? It will not move from there until I push it. If it needs energy to push it, which means it has mass. And once I push it, it will not stop. It needs energy to stop it. You see? But if something which doesn't have mass but is moving very fast, it also behaves like something. It is actually not. It's an illusion. So to move at the speed of light is impossible because the amount of energy you will need, because light is moving very fast. It has a momentum, it has very fast. It behaves like it is something and you cannot catch up with it. To catch up with it, you need so much energy that doesn't exist. That is why nothing can move. It is a law of nature. Nothing can move faster than light, although light can slow down, refract, bend, and reflect back. Interesting, right? And we are also made of light. We are also made of energy waves. which has collected some mass, so therefore we have stuff, body is like something. Okay? But it is made of the same vibration of energy as is light. But another interesting thing, how do you switch it off? Another interesting thing about light is that light is actually not light.
What is it? Oh yeah, we just named it light.
We call it light,
It could be called doom.
and why we call light?
I know.
Because when tiny particle, listen, this is very important. When a tiny particle switches its position around the atom, it loses some energy. Okay? Because if this is the center, I'm moving here, I need lot less energy to move. If I'm moving in big circle, I need more energy to move, right? So around the nucleus of the atom, there are lots of electrons moving. Some moving here, some moving here. There are 7 layers, right? Some moving outer layer. If the outer layer somehow comes here, it loses some energy because this energy it was using, now it's using less energy. Now what happens to that energy? That energy disappears into space, and that is a photon. A photon. Now it will keep going. It will keep going until it meets mass or more dense atmosphere. Okay? But why we see something, why we see light? Because this is the chart of electromagnetic spectrum.
Where's the baby?
Listen very carefully. This has all the frequencies of photons moving. Some moving very slow, some moving fast, some have a big up and down, some have tiny, right?
Tell them what frequency is.
So all these moving, there are infinite number of frequencies. I'll show you it again. So the frequency means how many times per second it reaches top or bottom, right? If I say like this, if I draw a picture like this, from this top to that top is one times. And from this bottom to that bottom is also 1. So in 1 second, how many times it happens is called frequency. And how up and down it goes, it is called wavelength. So this is the length of this wave from this top to this bottom. If it is going like this has a shorter wavelength, right? So from very short to very large wavelength, and from very fast to very slow frequency, energy is moving all the time, everywhere. Okay? Now, all that is light also if you can see it. But you cannot see it. Why? What is the secret why you can't see all the photons? Why you can't see all the vibrations of energy? Why only this light, which is, okay, that's too much technical detail, but of all the movements of the electromagnetic. Now, what is electromagnetic? It's very important to know. You may not understand everything, don't worry, right? Don't worry about the names, just get the idea. Electromagnetic spectrum is everything, everywhere that energy is moving. Why it is called electromagnetic? Because it is both electricity and magnetism in one. You see? Electricity, energy, is moving like this, and magnetism is moving at 90 degree, is perpendicular. Got it? So if energy is moving like this, in a three-dimensional concept, magnetism moving like this, energy moving like this, they're moving together.
Yep.
Sometimes they appear as electricity, sometimes they appear as magnet. One produces the other, they are both moving together. So that is the whole plan, of which somewhere in the middle, tiny area, okay, which is called light. Now why it is called light? Because nature gave you a little defect to have fun. Nature, all these things exist in nature, right? They're created in nature. But your eyes cannot see that. Your eyes can only see a tiny slice, a tiny rainbow light you see in the center, right? Tiny rainbow from red to purple, you see here? This is what your eyes can see, and therefore the light you see, which can be broken into 7 shades of color, this is what your eyes can catch. That's how your eyes are made. If your eyes were made differently, you could see this or that or that or everything. Right?
Okay, you can see this.
But nature is having a little fun with you guys. Say, okay, you try what you can see. And people have been trying this ever since they knew anything about it. They have been trying to see more, know more. But it doesn't happen. Then what they did? They say, with eyes you cannot see, but with your knowledge you can know. Okay? So they say, what kind of eye is that? So they imagine a third eye. Third eye. Third eye is not like this eye, is somewhere stuck inside your brain. It's not that. Third eye is that you can know more than these 2 eyes, which only know this. But it's from here to here. Actually, it's not only from here to here. It goes on forever. This side is going on forever this side. Okay? These are slower movement. These are faster movement. On the slow side, radio waves is very slow, microwave, and less than red is called infrared.
Wouldn't it be smart enough?
Then more than purple or violet is ultraviolet. Then there's X-ray, gamma rays, and so on and so forth. Right? Now you have learned something about X-ray, right? When they put X-ray vibration through your body, that is moving so fast that your skin, your muscles, your blood cannot interfere. It goes straight to something more solid, which is bone. Right? So it gives your bone structure inside through an X-ray machine. And gamma. Now these things become a little bit more dangerous because they can go through everything. Right now, right now, lot of this and lot of that is going through you, but only this.
Radio waves?
Everything is here. The whole real world universe is here, but you are seeing a tiny, you know how tiny this is? It's a trillionth of a trillion, that tiny. So that is the world we know through our eyes, but a bigger world we can know through our intelligence.